In this video, we'll be looking at resistors in AC circuits, and also we'll be introducing phasors. And this is covered in chapter 33.6 of the textbook. Okay, so we talked about, well, several chapters ago, we looked at what happened when you put a capacitor in a circuit. In a couple of the previous videos, we looked at inductors in circuits. So now let's think about a resistor in an AC circuit. So first off, just some circuit diagrams. So an alternating current power source is denoted by a little circle with a little sine wave in it. And so, of course, the simplest thing you can imagine is just taking your AC power source and directly attaching it to a resistor. So if that's all there is, well, then the voltage drop across the resistor is just going to have to equal the voltage provided by the AC power source. And so then the voltage across the resistor, again, just equals the EMF from the power source, so it's some maximum times some sine omega t. So, and we assume this is just a sine function, so basically that just says that the voltage is 0 at t equals 0. So, of course, Ohm's law still works, even though this is an AC circuit. It's just that the current through the resistor is changing, but the current is, or the voltage is still equal to I times R at every instant. So the current then as a function of time is just the voltage divided by resistance, which is going to be some maximum current times sine omega t. So the one thing to notice here is that the voltage and the current are both a sine function, which means they both hit their peak at the same time, and they hit 0 at the same time, and they're at the minimum at the same time. So what that means, or that's referred to as being in phase. So the current and voltage for a resistor in an AC circuit are in phase. Now things are going to get more complicated when we get to capacitors and inductors. So a useful way to look at it is to define something called phasors. So, and the way to think about a phasor, so you imagine the current and the voltage as an arrow. And then that arrow rotates in a plane. So the length of the arrow is just the maximum value. So the maximum current if it's the current phasor, or the maximum voltage if it's the voltage phasor. And then your arrows rotate counterclockwise with angular speed omega. And this angular frequency omega is the same that we saw in the, right, that's given in our AC circuit, right? That's for the same omega as in that sine omega t term. So then the angle with the x-axis at any time is just omega times t. Remember, angular speed is angle divided by time, so angular speed times time just gives you an angle. So the instantaneous value of either the current or the voltage is just the projection of that arrow onto the vertical axis. And that's if we're using the sine function, or we could have picked cosine also, in which case we'd be looking at the horizontal axis. So, and we're going to be doing some examples of these in class. So there's a nifty little online tool you can use here to actually show some of these phasors. And we'll be looking at the phasors for resistors, capacitors, and inductors in class.